AWS Well-Architected Labs, Operational Excellence Pillar, Lab Level 100, Inventory and Patch Management. Okay, so we're gonna go ahead and get started, and I'm just gonna go through the first lab. So if I click on Operational Excellence, labs, we're gonna start with the first one, which will be Inventory and Patch Management here. So what I'm gonna do is, as you can see, this is 100 Inventory and Patch Management Lab. Gives you the introduction, gives you the goals of the lab, and the prerequisites that are required for the lab. As a note, you will be billed for any applicable AWS resources used if you complete this lab that are not covered in the free tier. You will need a AWS account if you do not already have one. There is a video in this playlist that shows you how to go out and get you a free tier account with AWS. All right, so we're gonna go ahead and start the lab here. And the lab starts out with an intro, tells you about the lab, what you'll be doing. I'm not gonna read any of that. We're just gonna go right to the steps of the lab and go through them. So next step is requirements, users and group management, IAM, and everything. So the first step in this lab is starts at 2.1. This is the setup section. Create an administrator, IAM, user, and group. So what we're going to do is go ahead and click over here into our console home. I've already logged into my console. The first step, the setup 2.1, asks us to go ahead and create a user that is not the root user, add that user to a group with appropriate permissions to deploy resources, then sign out as the root user and sign in as that user we created. So if we look at our AWS account, what we'll do is in the recently visited, I would like to go to IAM. Now, if I've never been to IAM, I would simply go up into the search bar, type in IAM, press enter. It'll bring me the services list, and then I can click on IAM. It'll bring me to the IAM identity and access management page, and here's where we will set up our new users and everything we need to do, right? So what it says is we need to create a user. So on the left-hand navigation bar, we're going to click on users. Now, as you can see here, I already have some users created, but if I wanted to create a new user, I would just click add user here. I would type the username. I'm going to say test user. There can be no spaces in your username. I'm going to give this user programmatic access. That means they can log in via SSH and use the CLI, right? Or SDKs or API for that matter. I'm also going to give this user access to the console. That's where we were just at, and we can point and click to deploy resources and make adjustments. I can either auto-generate the password or I can put in a custom password. And I can require the password be reset or not, and then I would click next. So then it's asking me, do I want to add the user to a group? Do I want to copy permissions from an existing user or attach an existing policy directly to this user? We want to add our user to the group per the 2.1 instruction. So we would click, if you have a group created already, you would click it, admins group. If you don't, you need to create this group. You would press create group. You would choose administrator access if it's going to be an administrator, and you would create the group here. Since we already have that group created, we can simply select the group and then we'll click next. If we wanted to add any tags, we would add the tags, but we're not going to add any tags at this time. We would review what we've come up with and we would create the user. Now that I see success, the user has been created, I can download the .csv file with the credential information for this user onto my local computer. That way I can always have it. I can show the secret key. I can send this in an email to an email address. And so Now that that is done, you've got your user created, you've added them to the appropriate group. What you can do is open your user credential that you downloaded. As you can see here, it gives us some information and it gives us a console login link. We can simply copy this link and paste it in a new browser window, and it'll bring us right to where we need to be, and the account ID will already be installed for us. Now, typically this is a number, but I've created an alias for this account, so it shows my alias. So what I'm going to do is I'm going to put my username for my account I created and password. And I'm going to log into the account as the admin. And as you can see, now I am logged into the account as the admin. It says right here, lab admin at Gadget Tools Lab 1. So now that I'm logged in with my admin account, let's see what the well-architected lab wants us to do next. Okay, so it says create administrator, IAM, user, and group. We've done this. And now we're going to go to step 2.2, log into the AWS management console using your administrator account. Well, we just did that, so we can strike this one off, right? Next is create an EC2 key pair. Now you can name the key pair whatever you want, but if you're doing the well-architected labs, I recommend using whatever they suggest, because sometimes they'll have extra steps you can take in the lab that will be using the suggested names that they gave you, and you won't be able to, for instance, sort resources by a name that you created. Well, I guess technically you could, but it'll be easier to follow along with the steps by using their suggestions. So that's what we'll do. So I'm going to go ahead and copy this, and that's what we're going to name our key, right? And so we're going to go back over to the console. We're going to go to EC2. Over here on the navigation bar, let's scroll down to network and security, and we're going to choose key pairs. As you can see, we got some key pairs here, but we're going to create a new key pair. So we're going to click create key pair. Key pair name is going to be the name that they suggested. The key is going to stay RSA, and we're going to keep it a .pym file. Now they give you the option to create the key in .pym or .ppk. I would suggest always creating the key in .pym. This file is compatible with Linux systems. The .ppk is compatible with Windows systems. You can use a program like PuTTY to convert a .pym file into a .ppk file. As of this date, I don't know a way of converting the .ppk file into a .pym file. So if you create this as a .ppk and then you need to use it on a Linux VM that you created in the cloud, you're going to have a problem because you need a .pym file for the Linux system. So if you create it as a .pym, you'll always be able to stay compatible with Linux. But then if you need to, you can convert it to a PPK file for any Windows usage you may have. So that's just my suggestion. Always do .pym. You can add tags if you want. We're going to go ahead and create this key pair. The key pair is automatically downloaded to my local system in the local folder that always catches my downloads, and that is where I will leave them. So now we have our lab key file, right? And so now let's go back to the well-architected labs and see what else they say. So we created our key pair, we've downloaded it. Let's go to the next step. Deploying an environment using infrastructure as a code. We're not going to read that. We're just going to keep on going. Management tools and CloudFormation. This is going to give you some information on CloudFormation, which is what we'll be using in step 3 to deploy the lab infrastructure. I'm not going to read it. You can read it when you're going through the lab. Okay. So now what we're going to do is to deploy the lab infrastructure, download the CloudFormation script for this lab through the link. So when I click this link, it opens a web page and it gives me my CloudFormation template, right? This is code. This, when they say coding, someone actually sat up and wrote this out, likely, and that is coding. When it's a piece, when it's in one whole document, it's infrastructure as a code, and that's what this is. So this template will deploy EC2 instances with the name web server, with the name app server, and other Amazon resources that is needed to set up the architecture, right? And so ideally you would copy this code and paste it in like Notepad, okay? And then save that somewhere where you can retrieve it. So then it says, use your administrator account, the one we just logged back in with, to access the CloudFormation console, create the stack, select, it's walking you through the steps to create the stack, the CloudFormation template, okay? So then if we continue through the steps here, 5 through 8, it says on the select template page in the lower right hand corner, click view designer. This is going to show you what the designer looks like and what you can do inside of it. So we're going to stop right here and we're going to go and implement steps 1 through 8 here, and then we'll come back for step 9. Okay, so we're going to go over here to our console. And we can either click the services box and click CloudFormation, or we can type in CloudFormation here and click CloudFormation. Okay, so when you first come to CloudFormation, if you don't have anything available, on the left hand side you can see that there is a navigation bar. You can click on stacks. If you got stacks, you'll see them there. Stack sets, if you've got stack sets, you'll see them there, and so on down this list. We're going to create a stack with the CloudFormation template we downloaded previously, right? So we're going to say create stack. Okay, so now that we're going to create this stack using our CloudFormation template, what we want to do is we're going to say, how do we want to prepare this template? Our template is either ready, we're going to use a sample template, or we're going to create the template in Designer. Well, we already have a template ready that we downloaded, so we'll say template is ready. Now we got to specify the template. Or is it in an S3 bucket, or are we going to upload the template from a local machine? We're going to upload the template. I'm going to choose the file, and as you can see here, I've got a CloudFormation template that I downloaded. I named it OE100 CloudFormation. So it'll be Operational Excellence 100 CloudFormation template. That's what I named it, OE100 CF. I'm going to click that and open, and it's going to upload my template. I can go ahead and click next now. Now I'm going to create the stack name and set the parameters. And if you'll remember, we left away from our well-architected labs, and we'll go back there and see what we need to put in this place here. So let's go back here, and it says in the specified details section, define the stack name such as, okay, so this is going to be OE Lab Stack 1. I'm going to go ahead and copy that, and I'm going to paste it right here. That's going to be my stack name, right? Step 2, leave the instance type app and instance type web as default, free tier, T2 eligible, T micro value. Step 3, select an EC2 key that we created earlier. And we're going to define the workload name as test, and then it says go next. So that's step 10. Well, let's go and take a look at this. So the instance profile will do nothing. Instance type, we're going to leave as a T2 micro, and instance type web T2 micro. The key name we want to use is the one we created for the lab, and that's OE Lab IPM. And source location, typically AWS will want you to restrict this. Right now you can see it 0.0.0.0/0, which means traffic from anywhere. It doesn't matter where it is, it will be allowed. We want to restrict this to our own IP address, and I believe that the well-architected lab has something to say about that. So let's just go ahead and take a look before we go any further. Also, workload name, we were going to call it test. So let's take a look here. As you can see, test, yeah, we define the workload. Now let's see what it says about our IP address. It says in a browser window, go to Amazon checkmyip.com link. Let's go ahead and open that in a separate browser to get your IP. Enter your IP address in SSH location insider notation, i.e. ending in /32 for your single address. Now it says my address is 99.7.67.55. So we'll take that and we're going to bring it over here and we're going to paste it and then we're going to /32, right? So only my IP address can run this stack. And it's already set at test, and so we'll go ahead and hit next. Now let's go back and see if there's anything else in the well-architected lab we need to pay attention to. And so we hit next there, so we're now on number 11. On the options page under tags, define a key of owner and it says define a key of owner with value set to the username you chose for your administrator. Okay, so let's do that. The key is going to be owner. And my administrator is called lab admin, right? Let's see if there's anything else it wants us to do. You may define additional keys as needed. The CloudFormation template creates all the example tags given in the discussion on tagging above. Leave all other sections unmodified, scroll down to the bottom of the page and click next. On the review page, review your choices and then choose create. And then we'll stop there and come back, okay? So we've got the tag that they specified, and we always want to put the tag that the lab specifies because they'll likely call on it later. But we can also get in the practice of adding tags, and we'll add our own tags. So I'll say this tag is going to be created by. That is the key, and the value is going to be me, my name. So the key is created by, the value is me. I can add another tag that says, what is the purpose? So the key will be purpose, and the value will say OE lab. And that's enough tags. This is the way tags go. You can add up to 50 unique tags for each stack. And the more tags you have, the more ability you will have to search down resources by these tags granularly. Okay? You have the ability to set an IAM role. We won't do that right now. You have the ability to set the stack failure options, whether you want, if one component of the stack, so the resources you provision, if any one of them fails, it'll roll back the whole stack and nothing stays. It'll destroy the whole environment. Or you can preserve the successful provisioned resources and only roll back the ones that failed. I recommend rolling it all back and starting from scratch. You can do whatever you choose, right? There's advanced options. You can choose stack policy, rollback configuration, notification options, and stack creation options. We won't go through those at this time in the interest of time. So we'll go ahead and click next. This is the review. So we're reviewing our stack name here. We uploaded a template. We set some parameters. We set some tags. And that's all we did. Now we're going to go ahead and create this stack. And the stack is being created. As you can see, it says create in progress. We'll leave that for now and go back to our well-architected lab page and see if there's any other information we need to pay attention to, right? So that was 13. So now we're on 14. On the CloudFormation console page, check the box next to your stack name to see its details. If your stack name is not displayed, click refresh because it hasn't had enough time to finish creating it. If the details are not displayed, choose refresh button until the details appear. Choose the events tab for your selected workload to see the activity log of the CloudFormation stack. When the status of your stack displays create complete in the filler list, you have just created a representation of a typical lift and shift two-tier application migrated to the cloud. Okay, Step 16 says navigate to the EC2 console to view the deployed systems. Choose instances, select the server, and review the details under its description and tags. Optional, you can choose security groups and select a security group whose names begin with the name of your stack. Examine the rules and so on. You can also navigate to the VPC console and examine the configuration created by the stack there as well. So what we'll do is we'll go back here, and as you can see, we're still in create in progress. Let's do a refresh. The creation is still in progress, but what we're going to do here is we're going to look at the stack info. We're going to look at events. These are the events that the stack is going through as it deploys. If we go all the way down to the bottom, the first entry is OE lab stack 1. That was the first command. It says, okay, let's start creating it. Next, it created a VPC. It started creating the VPC. Next, it started creating the internet gateway. It created another VPC, another internet gateway, another VPC. It created a security group. This is the complete of the first VPC. It created a routing table, an ACL, a subnet. The internet gateway became completed. It created another routing table, and so on, all the way up the list until it was done. If we click refresh again, we'll see that the OE lab stack 1 create complete. So all of the steps it went through are done. The whole stack has completed. All right. These are the resources that were deployed and their IDs. App Server 1, App Server 2, attached gateway gives you their IDs, what types they are, and their status. Outputs, parameters, template. This is the stack template that was used to create it. Any change sets, if there are any, that's it. So we've created our first CloudFormation stack. Boom. Looking good, right? Okay, let's go back to our well-architected lab and see what's next. So let's keep on moving. We're going to go to step 4, inventory management. So in the next step, inventory management using operations as a code, management tools, and system manager. I won't read any of this for you. I'll let you do that on your own. It just tells you about the theory behind what we'll be doing in our next step. So setting up system manager. System manager is great because it allows you to automatically update or patch VMs, right? So that's going to be step 4.1, and we'll start at the first step here, and then we'll go and see if we can figure out how to do this piece here, right? So we'll go over here, and we want to go to IAM, and we want to go to roles. We're going to create a role, and we're going to use the AWS service for this role, right? And we're going to set up a use case for this role. And what we're going to do is this allows EC2 instances to call AWS services on your behalf. We want to use EC2, but if you click on the search box here and scroll down, you will see there's an EC2 section, and then we can choose the correct one. So we want the EC2 role for AWS System Manager, right? System Manager, that's what we want. So we're going to click that and click Next. As you can see, this permission, AWS EC2 role for SSM. This is the one we want. If you click the plus sign, it'll show you the actual code for the permissions and what it allows and what it disallows, right? And we've already got that, so we want to go to next. Okay, and it's asking for a role name and a role description. So let's see what our well-architected lab wants us to put there. So we're gonna go down here under attached permission, verify EC2, SSN. Yeah, we did that. Under tags, add one or more key and values for the tags, And then it says enter the role name as managed instance role. So we're just going to copy that and put it there. You can name anything you want, but like I said, I'm just going to be using whatever they suggest just in case some gotcha comes later. I've done it a million times. Try to deviate from what the actual lab prescribes, and then later on you find out you actually needed to do that, and so it's a pain. So we ain't gonna worry about it. We're just gonna do what they say. Accept the default in the role description and choose create role. And then step 7 is apply this role to the instance you wish to manage, which that's going to be an EC2. So, okay, we'll leave the description there. We can see what the JSON script for the code is, and you can kind of read it. Statement. The effect is it's going to allow. Who's it going to allow? The principal service of EC2. And the action it's going to allow is assume role, right? So Amazon's EC2 role for SSM, it is there. Tags. It did say add one or more tags. Let's go ahead and add a tag. And we'll say created by yours truly. That's all we need. We don't need to add no more tags. So we'll create this role. All right, we got our role created, right? So there it is right there. Manage instance role. So now let's go back to Architect Labs and see what they say. Okay, we got the role name, we put the description, we created the role. Okay, now it says we're gonna apply it to our EC2 instance. So step 7 says go to EC2, select the first instance, modify the IAM role, add the IAM role to the instance. So we're gonna attach our IAM role to the instance for all of our instances. Return to the system management console and choose Fleet Manager for the navigation bar, and in the node management menu periodically choose Fleet Manager until your instances begin to appear. Okay, so then we're gonna go here. So we want to go to EC2. We're gonna click on instances. And as you can see, we've got 1, 2, 3, 4 running instances that was created by our CloudFormation stack via the CloudFormation template. And so what we're going to do is we'll start with the first one, test web. We're going to go to actions. We're going to go to security. We're going to say modify IAM. Currently, there is no IAM role associated with this instance. That is what we're doing here. We're going to press this arrow and we're going to find a role that we created. Managed instance role. Here it is. Managed instance role. We're going to update. We're going to do the same thing for the rest of them. So click on to action, security, modify IAM role, and managed instance role. Update. Then we got, let's see, it was test web 2 action security modify managed instance, boom, and test 2 actions security modify managed instance role update. So now we've associated our managed instance role to our 4 running VMs or instances or whatever you want to call them, servers. And that step is done. So let's go back over here and see what they want us to do next. Okay, it says go to System Manager. So we're going to open up another window just so we can stay on EC2 here. This is going to be System Manager. We're going to go over here in the navigation bar. We're going to click Fleet Manager. There it is. And it looks like we got 2 instances already. Web 1 and App 1 on the test or dev side. Okay, that looks good. Now let's go see what else they say. If desired, you can use more restrictive permission sets to grant access to System Manager. Okay, next. 4.2, create a second CloudFormation stack. We're going to name it OE Lab Stack 2. The instance profile will be managed instance role, and the workload name will be production. So now let's go over here and we want to do CloudFormation. Now this production stack is going to create a whole new set of resources. So we're going to double our resource load. So we're going to create stack. Now we can create new with resources standard, or we can do it with existing resources, importing the resources. We're going to say new. The template is ready. We're going to upload it from a file on our desktop. In. Hit next. Stack name is going to be, they told us what they wanted it to be. Where is it? It's going to be OE Lab Stack 2. So let's just take that and paste it here. Paste. Leave the T2 micros. Definitely we're going to need to use that same key. We want to use our same source location, and we're going to make this one PROD for production, right? And we're going to slash 32 it. All right. Go next. I did owner, and it was going to be lab admin. There's my tag. Stack failure, we're going to leave. Stack policy, rollback configuration, notification options, and stack creation options. After the review, create the stack. All right, our stack is in creation in progress. We can watch it, create it as it goes by just watching the resources page or the events page. It'll tell you what's going on in real time, and then it'll finish it. Okay, so then I'm just gonna back up out of here and go to stacks and wait for that to get done. Now that's done, it says system inventory. Okay, so going to our steps, section 4.3, using System Manager to track your instances. It says under node management in the AWS System Manager, choose inventory. Scroll down in the window to the corresponding managed instance section. Inventory currently contains only the instance data available from the EC2. Choose the instance ID of one of your systems. Examine each of the available tabs. Inventory collection must be specifically configured, and the data types to be collected must be specified. Choose inventory, choose setup inventory, set up the inventory. Under specified targets, select specifying a tag. Under the tag, specify environment, and the key is going to be OE Lab IPM for the value. Okay, so let's go ahead and do the steps that we hadn't done yet. We'll go to EC2. We'll refresh the EC2 page. And as you can see now, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 instances running, 2 CloudFormation stacks. The first stack was deployed in US East 1C, and the second stack was deployed in US East 1D. It looks like they are still initializing, but we're going to go ahead and associate that IAM role with these, and we'll start with prod web 2. We're going to go to actions, security, modify IAM, and choose our managed instance role, update IAM. Go to app 2, actions, monitor, security, and that is not it, managed. There we go, update. And prod app 1, action, security. Make it the managed instance role, update. And next is, well, next, am I losing it? 1, 2, 3. Web 1, private web 1, action, security, modify, boom, managed instance role update. All right, we have attached that IAM role to our 4 new instances. The instances are all running. My stack checks are still initializing. They should be done shortly. So then let's go back. Inventory in the navigation bar. And we want to set up inventory. All right. And it says set up the inventory. Use specified targets by specifying a tag, environment, and OE lab. So here we're going to go to specify a tag under targets. And we're going to put a key and a value. Our value is OE lab, and our key is environment. Put our key in there. Boom. All right, what else does it say? You can select all managed instances in this account, ensuring that all managed instances will be inventory. All right, step 4 says schedule the frequency for which the inventory is collected. The default minimum period is 30 minutes. For collect inventory data every, except the default is 30 minutes. So no change there. Under parameters, specify what information you want to collect. Review the options and select the defaults. No changes there. Step 6, optional. If desired, you may specify an S3 bucket to receive the inventory execution logs. You will need to create a destination buckets for the logs prior to proceeding. I don't think we'll do this step 6 since it is optional. It just tells you how to go out and create your S3 bucket and to sync your logs to it. Choose Setup Inventory at the bottom of the page. To create a new inventory policy from inventory, choose Setup Inventory. To edit the existing policy from State Manager in the left, select the association and choose Edit. Note, you can create multiple inventory specifications. They will each be stored as associations with System Manager, State Manager. So going back to our System Manager screen, we're going to leave this as default 30 minutes. The parameters are all set as default. We don't need to add a path or anything else. If we wanted to sync the inventory execution logs to our S3 bucket, we would select this thing. It's going to ask for our bucket name and bucket prefix, but we ain't doing that part, so we're going to set up the inventory. Setup inventory request has succeeded. If we go here, you can see that we have an association. The status is pending. And if we want more information, we can just click on the name and it will give us what information it has. Okay, let's go back and see what else we got. System Manager, State Manager. So it's going to give you some information about State Manager. We ain't going to read through that. We're going to just move right on to section 4.4, review association status. And step 1 is under node management in the navigation bar, select State Manager. At this point, the status may show that the inventory activity has not yet completed. Choose a single association ID that is the result of your setup inventory action. Examine each of the available tabs of the data under the associated ID. Choose Edit. Enter a name under Name, optional to provide a more user-friendly label to the association, such as Inventory All Instances. White space is not permitted. And it goes on to give you more information about what you're doing here with reviewing the associations, right? So let's do that. Let's go over here to node management. We're going to click on State Manager. We got an association. We're going to click here. You can go through all the tabs, look at the resources that are Attached, some successful, some still pending. Targets, versions, blase, skippy. Definitely still pending. So we want to edit. And where it says name optional, we're going to paste our more user-friendly name in there and save the change. And our association name now says inventory all instances. Okay, we've done that. Let's go back. We did that, gave us some more information. Step 2, navigate to the node management. An association status has been established for the inventory instances under management. Choose an instance ID. So instances, go through all the tabs, navigate to compliance under node management. In the compliance resource summary and individual compliance status of the system corresponding management instances. So if we go back over here under node management and we click on compliance, we've got 3 compliant resources and 1 non-compliant. Let's just take a look. So it'll show us the non-compliant one. We can click on it. Severity is unspecified. Let's go back to our well architected lab. So system manager compliance. It says you can use the AWS system manager configuration compliance to scan your fleet of managed instances for patch compliance and configuration inconsistency. Tells you the default state of the configuration compliance. We're going to click on next step. And now we move on to patch management. System manager, patch manager. AWS Patch Manager automates the process of patching managed instances with security-related updates. Note, for Linux-based instances, you can also install patches for non-security updates. Gives you some more information about Patch Manager. Tells you about patch baselines. We're going to go right down into section 5.1 to create the patch baseline. All right, we're going to go through steps 1 through 4, and then there is some suggested information that we need to input. So let's go through 1 through 4. So let's go to here. We're going to go here. Patch Manager. We're going to view predefined patch baselines. And we're going to create a patch baseline. All right, now let's go back to our well architected lab and see what they want. For the name, it says Amazon Linux sec and non-sec baseline. Copy that and paste it here. Then it says for the description, copy this and paste it here. And then select Linux as the OS. We'll say Linux, where are you? Amazon Linux. Did they say Amazon Linux? Yeah, Amazon Linux. Step 5, in the approval rules for operating system section. Let's see where that is. Right there. Examine the options in the list and ensure that product, classification, and severity have values of all. So let's see. Product has an all. Severity, we want an all. And classification, we want an all. Okay, that's there. Leave the auto approval delay at 0. Change the value of compliance reporting to critical. 0. Critical for compliance reporting. And choose add another rule. In the new rule, change the value of the compliance reporting option to medium. Check the box under include non-security groups. Okay. Add a new rule. I assume we follow all the same steps. It was not specified, so let's go all. Leave that at 0. It wanted medium, and to check this box, include non-security. updates, right? So it says add another rule, compliance and reporting to medium, check the box under non-security. If an approved patch is reported as missing, the option you choose in the compliance reporting, such as critical or medium, determines the severity of the compliance violation reported in the system manager compliance. Step 6 says in patch execution section, in the rejected patches optional text box, enter system release stop. So let's go there. And it says patch exceptions and rejected patches. We're going to paste that in here. Okay. And here we do compliance reporting critical or medium, blah, blah, blah. System release. Okay. This will reject patches to new Amazon Linux releases that may advance you beyond the patch manager supported operating system prior to your testing and releases. For Linux operating systems, you can optionally define an alternative patch source repository. Choose the X in the patch source area to remove the empty patch source definition. Patch source area, remove patch source definition. Number 8 is choose create patch baseline, and you will go to the patch baseline page where you provided the patch baselines on your custom baselines. Patch sources. Patch sources. There is no source there, so there's nothing to remove. Let's go ahead and create the baseline. Okay, create patch baseline, succeeded, view details. Patch manager baseline ID 67 COA. So these are the settings we set up. Okay, next section talks about patch groups. A patch group is an optional method to organize instances for patches. It gives you some more information on that. We're going to go right on down to section 5.2, where we're going to assign a patch group. Step 1 is to choose the baseline ID of your newly created baseline. Choose actions at the top window and then say modify patch groups. In the modify patch groups window, under patch groups, enter critical. Choose add and then close. So it says choose our baseline. And must be the third one. Choose our baseline. Under actions, we're going to modify the patch group. And in the patch group, we're going to put critical in there. Paste and close that. Okay, so now that's done. Choose add and then choose close to be returned to the baseline. Okay. So then it says AWS run patch baseline. AWS run patch baseline is a command document that enables you to control patch approvals using a patch baseline. It goes on to give you more detail about this command. We're going to skip it. AWS System Manager document tells you about the AWS System Manager document in more detail. We're going to go right down here to 5.3, examine the run patch baseline in document. So step 1, go to System Manager navigation bar under Shared Resources and choose Documents. Click on Search box and then select Document Name Prefix and then equals. Okay, so we're going to go over here and we're going to say Documents. Document name prefix equals Control D, enter. Okay. Select AWS Run Patch Baseline and choose View Details. Review the content of each tab. AWS Run Patch Baseline here. Select. And view the details. Look at the content. Look at the versions. Look at the details. Look at the description. Okay. AWS System Manager Run Command. AWS System Manager Run Command lets you remotely and securely manage the configuration of your managed instances. Goes into a little more detail. Going right on to 5.4, scan your instances with the run patch baseline via the run command. Under node management in System Manager, choose run command. In the run command dashboard, you will see previously executed commands. Okay, let's get to there. Run command. This is the run command dashboard. Any previously run commands will be here. Okay, it says optional. Choose a command ID from the list and examine and record the record of the common execution. Nothing to see there, so we're moving on to 3. Choose run command at the top of the window. In the run command window under command document, choose the search icon and select platform types, and then choose Linux to display all the available commands that can be applied to Linux instances. Choose AWS Run Patch Baseline. So it says command document and choose a platform. Command document, platform, Linux, and then run. Did it tell us to choose Linux? Platform type, and then choose Linux to display all available commands that can be applied to Linux instances. Choose AWS Run Patch Baseline in the list. In the command parameter section, leave the operation value as the default scan. In the target section, under choose a method for selecting targets, choose specify a tag, and then enter workload and test. Okay. AWS run. So I chose the platform of Linux, and it's supposed to list all of the commands I can use. And I'm looking for AWS run update, but it's not in here. So I'm just going to paste it in my search box. Run patch baseline and hit enter. And I'm going to, okay, here we go. AWS run patch baseline. I'm going to go ahead and take it off Linux, and it should show me it for all. So the AWS run patch baseline works with Windows, Linux, or Mac OS, so it doesn't matter. I can click that. I can scan, leave scan to scan. I can specify instance tags, instance manually, or choose a resource group. Tags, I can go, what tags did I have? It said workload and test. Let's copy workload, paste, and then we'll go ahead here and copy test and paste it here. Paste. And other parameters, rate control, output settings, SNS notifications. We can set up a notification here. AWS command line interface command. Let's see what it says here. And click add. The remaining run command features enable you to. It's telling you what the rest of the features is. Gave you some notes. Goes into more detail. I didn't. Okay, now I added that. Okay, it says choose run. Okay, run. And its status is pending. Okay, scroll down to targets and outputs to view the status of the individual targets that were selected through your tag. Choose an instance ID and view the output. Targets and outputs. So it's still pending. Let's refresh. We got a success. Right here in targets and outputs, as you can see, we got 4. We got 4 resources. So we'll just click one. And step 1, output, step execution skip due to incomplete platform. Step name, patch windows. Step 2, output. The command output displays a maximum of 48 characters. User bin Python, snapshot ID, all of this, right? Okay, we've seen all of that. Node management, and we're going to choose compliance. On the compliance page in the compliance resource summary, you will now see that there are 4 systems that have critical severity compliance issues. In the resource list, you will be able to see the individual compliance status details. So we're going to go here, we're going to go back over here, we're going to go to compliance, and we've got 8 compliant resources, and 4 are in the critical and non-compliant sections. If I clicked on this 4, I suppose it would show me the 4 that were in non-compliant. Severity is critical, non-compliant, blase skippy, right? Patch your instances with AWS run patch baseline via run command. Okay, so step 1, under node management in the AWS system manager navigation bar, choose the run command. Choose the run command in the top right window. In the run command window, under command document, choose the search icon, select platform, then choose Linux, then C. Then it says AWS run patch baseline in the list. In the target section, we're going to go back and specify workload and test. In the target section, specify workload and test. Command parameter section and target section, right? So we're going back to run command here. Run command. We're going to run command. We're going to just paste the run command we want to see. AWS run patch baselines. We're going to select it. So targets, paste, TEST, and there was another section. Was it command parameters? Yep. Change the operational value to install. Operation value to install. Put the workload in the test. Enter a tag key. Yeah. In the target section. Why did it put that twice? Look at this. It says in the target section, under specified targets by, choose specifying a tag to reveal tags subsection. Under the enter a tag key, enter workload, and then enter test. And then it says in the command parameters, do operation value to install. Then it says in the target section, choose specified tag using workload and test. It's the same damn thing. Target section, specified target, workload and test. They gave it to us. They gave that step to us twice for some reason. Keep on going. Right here in the rate control section for concurrency, ensure that targets is selected and specify the value as 1. Rate control section. So let's see, rate. Currency set to 1. Area selected and specified as 1. Choose run to execute the command and go to the details page. Refresh the page, view, updated status, and proceed when the execution is successful. Warning, remember, if any updates are installed by Patch Manager, the patch instance is rebooted. So automatic reboot when an update happens. Okay, now run. And it is pending, right? Let's go back and see what else they got to say. Refresh the page to view updated status and proceed when the execution is successful. Okay, so we gotta wait for this. Okay, we are successful. And so we're gonna go back over to here and see what's next. 5.7 review patch compliance after patching. Under node management, navigate to compliance. The compliance resource summary will now show that there are 4 systems that have satisfied critical severity patch compliance. In the optional scheduling automated operations activities section of the lab, you can set up a system manager maintenance window and schedule the automated applications of patches. All right, let's go here. Go over to compliance. And sure enough, there's 4 systems that got patched here, and they are no longer in the critical resource category. Everything looks compliant. Everything looks nice there. So we can keep on going back there. Now, they gave you some information on the impact of operations as a code. I'll allow you to read that on your own time. We're going to go to the next step. Next step is creating maintenance windows and scheduling automated operations activities. All right, AWS System Manager maintenance windows. They're going to give you some information about the maintenance window. They let you define a schedule for when the platform or when to perform potentially disruptive actions on your instances. Let you read through that. We're going straight to step 6, setting up a maintenance window. So let's read and see what it says. Create a role under attached policy permissions, review the section, blase skippy, right? So apparently we're gonna have to create a role for this maintenance window. And it says, create the role that allows the system manager to task in maintenance window on your behalf. Navigate to IAM console. In the navigation pane, choose roles, then choose create a role. In the select type of trusted entity section, verify that the default is AWS service. In the choose service that you will use for this role, choose EC2. This allows EC2 instances to call the service on your behalf. Choose next and permissions. So let's go through those steps. And that was in the IAM console. And so we'll go right here. We'll go here. We will say IAM. We're going to click on that. We're going to click on roles. We're going to create a role. AWS service. EC2 allows the instance to call AWS services on your behalf. So we're going to go next. Add permissions. And so the permissions, what does it say about permissions here? Under attached permission policy, search for, let's go ahead and copy this. Check the box next to it and choose next to review. So let's search for this role here. Enter. There it is right there. SS maintenance window. Click and next. Now they want us to name the role. Next to review. We're going to name the role what they suggest here. So we're going to name it this. Paste. And did they offer a description? Role for Amazon. SS maintenance window. Put that there. Choose create role, and upon success, you will be returned to the role screen. Scroll down here. We ain't gonna have no tags right now. And we're gonna create the role. And we were brought back. The role was created. To enable the service to run tasks on your behalf, we need to edit the trust relationship for the role. So choose the role you created and enter its summary page. Choose trust relationships and then choose edit trust relationship. Delete the current policy and then copy and paste the following policy into the policy document field. Let's make sure we get this. Make sure you get it all. And we're going to go back here. Now, the role we just created is probably going to be SS maintenance role. That's this one right here. We're going to choose that. Trust relationship tab. Edit the trust relationship. Delete that and put in what we copied. Update the policy. Trust policy has been updated. And then step 5, update the trust policy. Copy the role ARN to your clipboard by choosing the double document icon. Okay, yeah, next to ARN. Okay, let's go back to the roles. We're gonna go to SS maintenance window, and I should see an ARN. Here it is. Boom. Copy the profile ARN. Okay. When you register a task with a maintenance window, you specify the role you created, which the service will assume when it runs the task on your behalf. To register the task, you must assign the IAM pass policy to your IAM user account. The policy in the following procedure provides the minimum permissions required to register tasks with a maintenance window. And we're going to be at step 7 to create the IAM pass role policy for your administrator's IAM user group. Okay, so we're dealing with IAM again. In the IAM console navigation pane, choose policies and then choose create a policy. So let's go there. IAM. We're going to choose policies. We're going to create a policy. All right, now what's next? On the create policy page, select the service area. Next to service, choose a service and then choose IAM. In the action section, search for pass role. Okay. Oh, no, that's not where we are. Services, choose a service. IAM. IAM. This is going to be pass role. Okay, we're going to check that pass role. Check the box. In the resources checks section, choose actions that require the role resource type. Then choose add ARN. Okay. Add ARN. List ARNs manually. Type or paste a list of ARMs. Paste the ARN in. Click add. There it is in there. Next step. Then choose add. Then choose review policy. On the review policy page, type the name in a box such as this. Choose create policy. You will return to the policy page. So we got that. Request conditions, none. Additional permissions, none. So we're going to go next. We're not going to add any tags. We're going to review. We'll put this name in here. It gives us a summary. And boom. Create the policy. Back at the policy page, the policy has been created. Okay, step 8. To assign the IAM pass policy to your administrator's IAM group, step 1, in the IAM console, navigate to groups. Choose your administrator's group. Under the permissions tab, choose attach a policy. So let's go take a look at that. We'll go here, IAM, go to user groups, click admin, click permissions, add permission, attach a policy. Pass role, we attach, add permission, policy attached to the user group. Thank you much. And that is done. Now we can actually get on to creating the maintenance window, right? So creating maintenance window, to create a maintenance window, you must do the following. Create the window, assign the targets, assign the task, right on to 6.2, create a patch maintenance window. Okay, so we're gonna open System Manager. In the navigation pane, choose maintenance window, then choose create maintenance window. In the provided maintenance window details section, in the name field, type a descriptive name to help you identify the maintenance window, such as patch test workload servers. We're going to copy that, and we're going to go in System Manager and maintenance window and create a maintenance window. And we're going to name it what the suggestion was. All right, let's move this over here. And then we've got optional. You may enter the description. Choose allow unregistered targets if you want to allow maintenance window tasks to run on managed instances, even if you have non-registered those instances as target. If you allow unregistered targets, then you can choose the unregistered instances by instance ID. When you register a task with the maintenance window, if you don't, then you must choose previously registered targets when you register a task with the maintenance window. If you click unregistered targets, you can choose any of your instances. If not, then you have to only use registered targets. So it says specify a schedule for maintenance window by using one of the scheduling options. User specify with accept the default cron job scheduler. So description, allow unregistered targets is by default marked. We'll leave it. Schedule, we're going to schedule it by a cron schedule builder. Okay, it says under Windows starts, choose the third option, specify every day and select a time at 2. So we're going to say daily, every day at, what was it, 2 o'clock? 02. Okay, and in the duration field, type the number of hours the maintenance window should run, such as 3. In the stop initiating task field, type the number of hours before the end of the maintenance window that the system should stop scheduling new tasks to run, such as 1 hour. So 3 and 1. So the duration is going to be 3 hours, and the stop initiating task is going to be 1 hour. All right, optional. You have the maintenance window execute more rapidly when engaged with the lab. Yeah, I'm gonna just leave the initial suggestion. I don't need it to happen while I'm on this thing. So we're gonna say start date optional, end date optional, schedule a time zone optional, offset optional, create maintenance window. Okay, we have a maintenance window with an ID, patch workload servers enabled, Saturday, blase Skippy, right? 6.3, assign targets to your patch window. After you create a maintenance window, you got to assign some targets to it, right? So step 1, on the maintenance window page, choose window ID of your maintenance window, then choose actions, then choose register targets. So let's do that. Do actions, register targets. All right. In the target name field, do test web servers. So let's put that. Optional, enter the description. Optional, specify the name of the work. Note, owner information is included in any CloudWatch events that are raised while running tasks of these targets in the maintenance window. In the target section, under select targets by, choose default specifying tags. And we're going to do instance role and web servers. So under, okay, specifying tags. Under tags, enter workload and test, and then a second value of instance role and server. So go down here, targets, specify target with tag. Instance role and web server. We're gonna add that one. Choose register target at the bottom of the page and return to the maintenance window. If you want to assign more targets to this window, choose the targets tab and choose register a target to new targets. With this option, you can choose a different means of targeting. For example, if you previously targeted instance by instance ID, you can register new targets or target instances by specifying EC2 tags. All right. So we registered the targets, test servers, 2 targets. 6.4, assigning tasks to your patch maintenance window. After you assign the targets, you assign the tasks to be performed during the window. From the details page of your maintenance window, choose actions and then choose register run command task. In the name field, put that. Action, register run command task. In the name, put this. Optional enter description. In the command document, select platform and then choose Linux AWS patch baseline. And this time, no description, task invocation cutoff. Okay. Platform Linux AWS. See, it's not in here for just Linux. No AWS run command for just Linux. But if I put run patch baseline, and as you can see, AWS run patch baseline, it's automatically set for all 3 platforms. So it's going to run 3 steps when it runs this. And it's just, if there's a Windows instance, it'll do Windows. Linux instance, it'll do Linux, and Mac, it'll do Mac. So we're just gonna choose that and leave the task priority at the default value of 1. Okay, in the target section, so let's see, task priority as a default, that is 1. And then we got targets. Select the registered target group, which is this one. Leave the task, blah, blah, blah. Yeah. In the rate control section, currency, do 1, and error threshold, do 1. Concurrency 1, error threshold, whoops. Error threshold 1. In the role section, maintenance window role. I forgot we did that. Where is it? Service role, maintenance window role. It's the ARN, this role. But what if I just typed the name of it in here? Okay, it would find it for me, which is here. Okay, cool, it's there. Next, output options. Leave, enable writing to SC clear. Specify output options to record the entire output as 3. Nope, we ain't gonna do that. Nope, only the last 2,500 characters of the command document output are displayed in the console. To capture the complete output, define an S3 bucket. Yeah. Nope. Okay, SNS, enable SNS. Are we gonna do a SNS notification this time? And SNS, leave SNS clear. No, I guess we ain't gonna do it now. It'll be later. In the parameter section, do operation, select install, choose register run command task to complete. We're gonna do install, register run command task. 6.5, review maintenance window execution. After allowing enough time for your maintenance window to complete, navigate to, okay, so we did not set our maintenance window to go while we were doing this thing. So it's likely that we're not going to get any information, but we're going to go through the motions. So we're going to go to System Manager. We're going to choose window. We're going to choose maintenance window and then choose the window ID for the maintenance window. On the maintenance window ID page, choose history. Select Windows Execution ID and view the details. On the Command ID detail page, scroll down to Target Outputs, Instant ID, and view output step 1 and 2. So we're going to go over here. We're going to go to maintenance window. We're going to click on the ID, history, and there's no history because we did not set it to happen right now. It actually, I think we set it for tomorrow. So if we did set it to go right now and we sat and waited the time, the history and the status and everything would be here. So we don't need to actually go through that step to do it. It says you have now configured a maintenance window assigned tasks, assigned tasks, and validated successful execution. The same procedures can be used to schedule the execution of any AWS manager document, right? And moving on to the next step. Creating a simple notification service topic. And it gives you some information about that. I believe we've created one of these before on this playlist, but we gonna go through it, right? This is the step 7, creating the SNS topic. Interestingly enough, it's marked 6.1 here, but who cares? All right, we're almost done with this lab. To create the subscribe to an SNS topic, to create and subscribe to the topic, step 1, navigate to the SNS console, create a topic in the create new topic window. In the field type, select standard. In the topic name, do admin alert. In the display name, do the same, and then create the topic. So let's go over here. We're going to say SNS. We're going to go to topics. We're going to create a topic. It'll be a standard topic. Topic name is going to be, did we say this was going to be the topic name? Admin alert. Display name will be the same. Paste. Encryption is optional. Access policy is optional. Delivery, retry is optional. Delivery status is optional. And tags are optional. You would just hit create topic. And you would create the topic. It says topic created. Now that you've created the topic, you got to create a subscription to the topic. Here we go. We're going to create a subscription to this admin alert here. And the protocol is going to be an email, and we're going to put an email. And after your subscription is created, you must confirm it. Yeah, we know. Subscription filter policy is optional and redrive policy is optional. We're going to go ahead and create that subscription. Now we should get an email in our email to confirm the subscription. So let's go to the email. Oh, I just heard it come through. And we're going to subscribe to the subscription. Inbox. Admin alert. Look at that. AWS notification subscription. We're going to confirm this subscription. And we are subscribed. Okay, let's go back here. It says you will receive your subscription ID pending blah blah blah. Confirm subscription. Refresh the page after confirming to view the populated subscription arm. And you can now use the SNS topic to send notifications to your administrator user. Next step. And removing lab resources. So even though we just created that subscription and we added our email, we confirmed it so we know that we're getting the emails. Whenever we do some maintenance window stuff, it'll send us an email, right? Because we subscribe to it. So we don't actually have to see that to know that's going to happen though, right? And so removing lab resources. This is the end. We completed that lab inventory and patch management. It is a level 100 of the operational excellence pillar of AWS well-architected framework. So it says here, 7.1, remove resources created with CloudFormation. So I'll show you how to do that. We're gonna go, let's close some of these extra windows here. And we're gonna go to CloudFormation. And I always do that. CloudFormation. And the good thing about CloudFormation, see, we got routing tables, VPCs, EC2 instances, all kinds of stuff deployed in this environment, right? And without CloudFormation, one, we would have to go and create all of this stuff independently, each one at a time. And also, when we're done with it, we would have to go and destroy each one, one at a time. But with CloudFormation, we can just delete the stack. CloudFormation is going to go out there and delete all of the resources that we have in use auto-magically, right? So we're going to click on stack 1. We're going to say delete. Yes, we know. We're going to delete it. Deletion is in process. We're going to click on stack 2. We're going to say delete. Deleting the stack will delete all stack resources. Resources will be deleted. Delete. So these will get deleted. What else do we have to delete here? System Manager console. Choose State Manager. Select the association you created and choose delete. Okay, so we got to delete the association that we made in System Manager. So let's go to System Manager. And we're going to go to State Manager. And there's our association and the ID. We're going to say delete. We're going to delete that association. Instantly gone. Then we're going to go back and we're going to say, oh, S3. Remember when we didn't create that S3 bucket? Yeah, we ain't got to delete it. Gone. If you created an SNS topic, we did. Now, you don't have to delete this. You're not getting charged for having a topic and being subscribed to it. But we will go ahead and delete that as well. So we're going to go over here. We're going to go to SNS. It's going to take us to our topics. We're going to click that topic and we're going to delete. Yeah, delete me. And we deleted our topic. Okay, the maintenance window. We created a maintenance window. We want to delete that. So we're going to go to System Manager. And we're going to go to maintenance window. Where are you? Oh, here it is. There's that maintenance window. Again, you're not being charged for this. You don't have to actually delete it, but we're going to go ahead and do it. Delete here. That way, if we want to do this lab again or whatnot, we won't have this stuff in our way. What else? If you did not intend to continue use as an administrator, I'm going to keep my administrator account, so I ain't deleting that. If you do not intend, if you don't want to get rid of it, it says enable MFA. We'll take it under advisement, right? Thank you for using this lab. The lab is complete. So we're going to click complete. Congratulations. You have now completed the lab. If you have implemented this knowledge in your environment or workload, you should complete a milestone in the well-architected tool. This lab specifically helps you with OPS 5. How do you reduce defect, ease remediation, and improve flow into product? And it looks like a clickable link. So that's what we're going to do. We're going to click on it and see what it brings us to. Also, the well-architected tool has a link here. And so let's open another window for that one. So let's go to the page. OPS 4, how do you design your workload so that you can understand its state? Design your workload so that it provides the information necessary across all components. For example, metrics, logs, traces. For you to understand this enables you to provide effective responses when appropriate. Best practices: implement application telemetry, configure workload telemetry. How do you reduce defects? This is all good reading. This is part of the well-architected framework, the pillars of framework. Here is the well-architected tool: learn, measure, and build using architectural practices. See that? All right. So we are done with the lab. And this is, the base level, but this was a doozy. This is not hey, I just did my cloud practitioner and I'm ready lab. I don't think you could go in here and do this lab with just fresh cloud practitioner knowledge, because even that knowledge is still fresh in your head. Some of this stuff, you could potentially do it, but it would take hours and hours and hours to do it, because you're going to have to read every word and go back and look and check, and it'll turn up being a lot, right? So that's going to be it for this lab. We're going to bring this one to an end. And if you've enjoyed this content, if this content has been beneficial to you, you should really consider smashing the like button for me and clicking the bell icon so that you'll be notified when new videos are dropped. And until the next video, Tech Fam, peace.